corporate finance practice problem with the use of Excel. Future value calculation compounding quarterly. Wanna Finance Corp. Exercise Corp Finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab then having basically an answer key for it. We're going to have our information up top to the left. We're going to put that information into the blue area on the right. We will do so in a few different ways. One with a mathematical formula. We will then have a running balance type of calculation, Excel function calculation, and then the use of the tables with ending it out at table time. Going back on over to the information on the left, we have a future value calculation. We've seen that in the past. The difference here being that we're going to be compounding now quarterly. So you got to be careful when you're thinking about the compounding so that we treat the years. We're given the information in terms of years, but compounding quarterly. Therefore, we got to be careful with the periods that we're going to be using as well as the percentage rate that will be used. So the invest, we're going to imagine investing the 150. The years are going to be 5, but we're compounding quarterly. The percent is 16, but once again, compounding quarterly. We'll start it off with the formula down below, the future value equaling the present value times the 1 plus r to the n. Present value being that 150,000, r being the 16%, but we're going to have to adjust it for the quarterly, and then n being the 5 years, but once again having to adjust that for the quarterly compounding. So we'll start off with our formula up top, and we're going to break this down into a table format as we've seen in the past. Outer column having the present value times the 1 plus r to the n, then bringing that enter calculation in here for the 1 plus r to the n. So this is going to be equal to the 150,000. Nothing really new there. Then we're breaking out the 1 plus r to the n, which is going to be 1. And then we have the R, which is 16 here, but compounding quarterly, this percent needs to be matching what we're going to be using for the periods. So I've got to break this down. I've got to take that equals the 16 divided by 4, because there's 4 quarters. So divided by 4, and let's percentify this, home tab, number group, and percentify that. Now note, this is a fairly high percent, so even when we break it down to quarterly, which would be like the percent for a 3-month time period, because there's, 4 quarters of 3 months in the year, still something that's fairly high, a 4%. But just note that if you had something over here like a 2%, and you look at the quarterly amount, it's going to be something much smaller over here. That's why typically and customarily, we will record the percent in a yearly kind of percentage unless it's said otherwise. That's just basically the custom that we will have, and then we'll have to then adjust it when we have some kind of compounding or need to use it for some period other than a year, in this case it being quarterly, therefore taking the 16%, dividing it by the 4 quarters to get the 4% of a quarterly rate. I'm then going to underline this, home tab and font group and underline, home tab, font group, underline, sum this up equals the SUM, summing these items up. Then we'll go ahead and percentify this, go into the home tab, number group, percentify, so there's the 104. Then the number of periods, this again needs to match up to the quarterly compounding. There's 5 years, and there's 4 quarters per year, so the periods that we're talking about then are going to be the 5 times the 4 quarters, or 20 periods. 20 periods. And then home tab, font group, underline, we're then going to take this to that period. So this is going to be equal to the 104, shift 6, caret of the 20. Adding some decimals here, home tab, numbers, adding some decimals. So there we have that. Then home tab, font, and underline. Then we can multiply these two items out, this being the 150,000 times that amount we just calculated for the 328,668. Let's add a couple decimals there. Home tab, numbers, add a couple decimals. Now let's do this with a running balance type of calculation, and we'll calculate the periods on the left-hand side. So the periods are going to be 1, 2, but these are not periods in terms of years, but rather quarters. So these are going to be the quarters, quarter 1, quarter 2, and so on. And I'm going to bring this all the way down to the 20 quarters that we have, and then we'll break this out on a period-by-period calculation, quarter-by-quarter calculation. We'll go to the Home tab and then the alignment and center that. So there we have that. And now we're going to be calculating the first value, the 150. I'll just bring that outside here. This is going to be the 150. And then let's calculate the interest. The interest is going to be equal to that 150 times the 16%, but that's a yearly rate, and this is a monthly thing. Therefore, we have to take that and divide it by 4. It's not monthly, this is quarterly. Therefore, we take it and divide it by 4 to give us the quarterly amount. So note what we did here, and let me just do that calculation a long way just so we could see it. If we had 150,000 times the 16%, and I percentified this down here, we could say this is going to be equal to this 150 times the 16%, and then say that would be per year, but we're doing it per quarter. Take that and divide it then by 4. This is the format that makes most sense to me if I was to break this out in like a table. But when we use the Excel formulas, note you can also calculate this as basically the 150,000, and then instead of the 16%, I'm going to say this equals the 0.16 divided by 4, giving us that quarterly percentage rate. There's the quarterly percentage rate, and then I can multiply this out in that format, and there's the 6,000 that way. So you can calculate this the two ways. When I'm thinking about it in my head for long-term calculation, I usually do this, because when you then decrease the interest rate, once again, you get to a small interest rate. So like if you're doing it longhand, it's probably easier to think about it this way. But when you're doing formulas, often you will then think about it this way, adjusting the interest rate. So let's continue on here. We're going to say this is going to be then equal to the 150 plus the 6,000. So that's the 156. Well, let's do it again. This is going to be the 156 times the 16%, but then divide that by 4 to get the quarterly amount. There we have it. So it's going up a little bit. We can see it compounding quarterly. Prior balance plus the current interest we then have. Let's do it again. This is going to be equal to the 162,240 times the 16% for the yearly rate, but then divide that by 4 to get the quarterly amount. It's going up there. We can see that's for the fourth quarter. We have the last amount plus the current interest. We'll do it one more time, and then we'll copy it down. This is going to be equal to the new balance times the 16%. Then we're going to divide that by 4 again. We'll pick the prior balance plus the new balance, and there we have it. Let's copy this down and see if it'll work. I'm going to use the autofill going down one cell, check it, it won't be right, then we'll fix it, then we'll do it again. So I'm going to highlight these two, or select them, I believe is the proper term, and then use my autofill handle to autofill them down. This one is clearly wrong. I'm going to check out and see what happened with it, double clicking on it. I see this 16 cell move down. It shouldn't have. I want to make that an absolute reference. That's in cell B4. So I'm going to then select these two again, delete them, go back into the cell, find B4 right there. What's B4? It's B, that's the cell. And then we're going to say F4 to put an absolute reference on the B4 cell, which means we put a $ before the B, $ before the 4. You only need a mixed reference, but absolute reference works, and it's easier for me to remember. So that's what we do. So I'm going to then select these two. I'm going to then highlight them and autofill them all the way down. Not even going to check it. We're living dangerous here. I'm just going to take it all the way down to the 20 periods. I don't know why I have 21 down here. 20 periods, right? Yeah, that's going to be the 316.027. I actually should have taken it down and renamed this. You can see that didn't come out quite right. The reason is because I should be naming this as period 0, and then period 1. So I'm going to rename these cells, select them all the way down. So now we got 20 periods starting at 0, gets us then to that 328,668. You can see this is a tedious thing to do if we were to do it by hand, because as we go to compounding for something more than a year, compounding quarterly or compounding monthly, then the periods become a lot longer, but still easy to do with Excel if you get the functions in there correctly, if I set up the table correctly at least, because then you can just auto-fill it down. I'm going to add a couple decimals, Home tab, numbers. Let's add a couple decimals here. So there's the 328,668,47. same as the item we got on our last calculation. Let's use the Excel formula to do it now. So this is the easy, magical way of doing it, but we got to be careful once again that we're picking up the proper interest rate. So let's see what the difference will be here. We're going to say this, we'll say that this is going to be equal to, we'll have the future value. Future value, we'll pick up the rate then over here. We're going to pick up the rate at 16, but that's the rate for a year. And this is quarterly, so I got to divide it by 4. If it was yearly, we would divide it, monthly, we would divide it by 12. So that's going to be the tricky component. Make sure you're lining those up. And then we got the number of periods, which once again are given to us in years, but they're compounded quarterly. So we got 5 years compounded quarterly, so we're going to take that and times 4. If it was monthly, we would have to multiply it times if it was monthly, we'd have to multiply it times 12. So if it was monthly, these two would be 12s instead of 4s. And then comma, we're not going to have a payment because this is not an annuity. So I'm going to say comma again, and we need then the present value, which is the 150,000, and enter. So there we have it, and so there matches that. Let's go ahead and make it a positive number by double-clicking on it, going before the F, putting a negative there, flipping the sign, so that looks good. Let's do it one more time, this time using the table. So table time, which also is an area where we got to be careful that we're picking up the proper amounts from the table, proper interest rates, proper periods. So we're going to start with the 150,000. Going back on over, if the data gives us 5 and 16, but they tell us to compound quarterly, we have to once again take that 16, divide it by 4 to get basically the 20. Take the 16 divided by 4 to get the 4, and we got to take the 5 and multiply it times 4 to get the 20. So on our table then, we're looking at periods. The table does not represent years and yearly percentages. It represents periods and the related percent per period. The periods we're talking about now are quarters, and therefore the percent is going to be the 4%. Also note that if a book problem forces you to use tables, then they're going to have to give you kind of like round numbers over here because the tables only have those. They don't have a more nuanced decimal percent. So you're usually going to be working with kind of the same type of numbers if they're going to make you compound in that format so you can find it on the table. So we have the 4% and 20, 4 and 20, 4 and 20, 420, 420. Okay, 4 and 20. So we're going to go down here, 2.1911, 2.1911, 2.1911, 2.1911, 2.1911, adding decimals, home tab, numbers, decimalizing it, and then home tab font, underlining it, and then multiplying it. 150 times the 2.1911. Let's add a couple decimals here. Home tab, numbers, add a couple decimals there. We're at the 328,665, slightly different than the 328,668.47. That's due to the fact that we have rounding, this going out only to 4 digits. If we were to see how far it would go out after 4 digits or something closer, it would be something looking more like that. 2.19112314 instead of just cutting it off at the 2.1911. That difference not material for decision-making purposes typically, but might be used by devious test-making, multiple choice formatting people to try to force you to use one method or another. So beware.